Alright, in this video I'm going to teach you about isotopes. So I mentioned in the last video that the mass number of a particular atom is not universal to a specific element. So, and vice versa. So if an element has a mass number of 12, we can't say for sure what element that is. Similarly, if we know what element it is, if we have chlorine, we can't say for sure what its mass number is. Okay? And in the situation that we have multiple atoms of the same element with different mass numbers, which is possible, we would call those isotopes, isotopes of each other. So for example, let's look at chlorine. So chlorine has two common naturally found isotopes, which are chlorine 35 and chlorine 37. Okay, this is one way of writing those isotopes as we talked about in the last video. And you could create other isotopes of chlorine in the lab, but these are the two that are commonly found in nature. And certain elements will have two naturally occurring isotopes. Some will have 5 naturally occurring isotopes. Some just have 1 naturally occurring isotope. Okay? And so isotopes, sort of grammatically, the word is used kind of in two ways. One is that we would say these are isotopes of each other, and then we could also say that this is one isotope of chlorine, and this is another isotope of chlorine, or we could say the chlorine 35 isotope. Okay, so that's a few ways that the term is used, but it's referring to this idea of, how a particular element does not have to have a specific mass number. Okay, so the same element can have multiple different mass numbers, and when that's the case, we call those isotopes of each other. And we also sometimes use it to refer to one particular element mass number combination. That is one isotope, and that's another isotope. And so one question they could ask you about this, is how many, we kind of did an example like this in the last video, but how many protons and how many neutrons are in each of these? Well, they're both chlorine. So if we look at the periodic table, the atomic number of chlorine is 17. That tells us the number of protons. So this has 17 protons regardless of which isotope we're looking at, because they're both chlorine. And then the mass number is the protons plus the neutrons. So the neutrons is going to be the mass number minus the number of protons. So this one, 35 minus 17, has 18 neutrons, and then this isotope, 37 minus 17, has 20 neutrons. So we see that another difference with isotopes is that they have different number of neutrons. Okay? They're going to have the same number of protons because they're the same element. But if they're the same element, meaning they have the same protons, but they have a different mass number, then they must have a different number of neutrons. Okay? So these are isotopes. Now keep in mind, if we had, let's look at another example of what would not be considered isotopes. So let's say we had 32p, and we had 32s. Okay, these would not be isotopes of each other. This is sort of the opposite. They have the same mass number, but they're different elements, and that can happen as well, but we do not call those isotopes. There's really no special name for this, for the relationship between these. And if we just wanted to consider how many protons and neutrons were in these, well, phosphorus has an atomic number of 15, so it has 15 protons, and then 32 minus 15, 17 neutrons, and then sulfur has an atomic number of 16, so it has 16 protons and then 32 minus 16. So 16 neutrons. So again, this can happen, okay, but these are not isotopes of each other, okay? Isotopes is the opposite. Same element, but different mass number, which means same protons, but different number of neutrons.